This is a physics question dealing with one-dimensional kinematic motion. Difficulty is medium. This question involves catching up after an elapsed time. So we have a scenario where there are two runners. One runner stops and ties his shoes for 3 seconds. The runner B continues with constant velocity. Runner A is going to accelerate until reaching 16 feet per second, which he will maintain. What we want to find out is how much distance is covered when they finally are at the same position, okay? And we also want to find out how much time has elapsed, okay? So the time it takes for them to be at the same position, how much distance is covered, okay? So we have the first part, right? At t equals 0, their initial positions are the same. They have 0, okay? Now, at t equals 3 seconds, the position of B is going to be here because he maintains his constant velocity of 13.2 feet per second, okay? You have not moved. You're tying your shoes, okay? So we need to find out position of B, right? So since he maintains constant velocity, it's just his constant velocity times the 3 seconds, okay? Now what we're going to do is we're going to find out the next segment, right? So this is after t equals 0, after t equals 1, and this is now you're going to start accelerating, okay? So for me, this is the third segment. That's how I keep track of it, okay? So I count t equals 0 as one segment, and then t equals 1 is the second segment. This is going to be the third segment, okay? So now what we're going to have is the third segment is equal to, obviously since you're accelerating, you don't have an initial velocity and your initial position is 0, okay? So it's half at squared. Solving for t is just the velocity divided by the acceleration, okay? So now t squared is va squared over a squared, right? So that means we're left with this, simplifying, canceling the a, right? Because we have a squared underneath a, so that cancels. We're left with va squared over 2a, right? Okay, so now position of the third segment of B is going to be his second position, right? Which is after you're done tying your shoes. And then plus his position after you're done accelerating, right? So now what we want to know is in the duration where you're accelerating, do you catch up to your friend or do you pass him or are you still behind him? So what we're going to do is we're going to have to find out what these values are. Okay, we want to find out what position you have after you accelerate and what position your runner B has after after A accelerates, after runner A accelerates, okay? So now position of B at segment 3 is equal to this, right? So now here we can just factor out average velocity B and we get T1 plus that, right? Okay, this just stays the same, right? So if runner A's position is equal to or greater than runner B's position, then that means he caught him at the end of the duration, or if it's greater than, that means he overtook him, which means we need to go back and find out where exactly, right? Because the question wants to know how much distance has passed when they're at the same position and how much time has passed, right? So plugging in the values, we find out the runner A's position is less than runner B's position. This means that you're still behind him. Plugging in the values, we have you are at position 42.7 feet and runner B is at 110 feet. Okay? Sorry, I keep referring to runner A as you. Okay, so this is the last segment, right? So this is after you tie your shoes, after the acceleration. Now we have the third time interval, or the third time duration, which is where you maintain your velocity of 16 feet per second, okay? Then we have runner A. This is after he's accelerated, and plus his duration where he holds his constant velocity, okay? So now setting these two positions equal to each other, since we know that runner A is basically going to catch up and pass runner B now in this final segment for sure, theoretically, right? We have plugging in position, final position for B, we have this, right? This is his third position. Remember we solved that. We factored out VB, we have that, right? So this is his third position plus the last duration. Then we have your third position, remember, plus the final duration, right? Where you hold your 16 feet per second. Now what we want to do is we want to reorder this equation, and we want to get T3, we want to get the terms of T3 on one side, and we want to get the other side over here. Now since VA is greater than VB, it makes more sense to have, minus VB and add it over here. Add a negative, right? And then minus this and add that negative over here, okay? So then we get this equation, right? Forgive me, I went ahead a little bit. So what we're left with here, obviously, is VA, T3, and then we got rid of that one. That one's over here now on this side of the equal sign, right? And we brought this one, and we brought it over here. We minused it, okay? So now what we're going to do is we're going to factor out T3, okay? So we factor out T3, and we have VA minus VB, right? And then times T3. So we're going to divide by VA minus VB, right? That cancels out. That leaves us with just T3 over here. Delta T3, which is the duration of the last segment, right? Now we have this divided by this is going to give us our T3. Okay, so now plugging in the values for that, right? Since we know everything, we know what constant velocity of B is, we know T1, we know this, we know these values, velocity of A, his acceleration, we know all of this, right? Some of this we've already solved for, so we could just keep those, plug them in again, whatever. We end up with the duration of the third segment is 24 seconds, okay? So keep in mind, this is not the total time, okay? So the total time is equal to the first segment, which you're tying your shoes, right? So 3 seconds pass. So you stop, you tie your shoes, 3 seconds have passed, right? Then we have the second segment in which we have an acceleration, right? So now we have the time of acceleration. Then we have the last segment, which is where you're done accelerating, in which you maintain a constant velocity of 16 feet per second, okay? So we're going to add all of these up, and that's going to give us our time total, okay? So the only one that we didn't know, or that we had to solve for in the end, was T3, right? TA, the time to accelerate, is just the velocity over the acceleration, right? And then T1, we were given, right? That's 3 seconds. That's the time it takes for you to tie your shoes, right? So adding those up gives us 32.4 seconds. Now, I did 3 significant figures here. Keep in mind, this means roughly. If this was on your homework, obviously it would be 2 significant figures. We have 3 significant figures here, but everything else is 2 significant figures. That means in our final answer, if this was done in your homework or you turn it in, you would round this answer to, 32 seconds, correct? Okay, so now as a check, we can plug in to find out if these final positions match, right? So we're going to find the final position of B, which is easy. He maintains constant velocity, right? So that's just 13.2 feet per second times the time total, and that's going to give us 427.4 feet, right? Okay, so now we're going to do the final position of A, which is a little bit more trickier, but not too bad, right? We've already solved this. All we need to do is just plug in the values for these, add them up, and we get 427.4 feet. So these two positions are the same. That means this is the distance that is covered when runner A catches runner B, okay? This is the distance that is covered, and this is also the position that they're at, okay, in this question, since it's one-dimensional and everything is constant, right? Assuming that you run at a perfect 13.2 feet per second during the whole time, right? And you tie your shoes for 3.0 seconds. So we've solved for final position and we solved for the time total, okay? So yeah, that's it. If you have any questions or if you have any other problems that you want me to solve, let me know. A lot of the stuff I like to do, and obviously I like to write it all out in algebraic form. Then I plug in my values at the end. So yeah, but that's it. Thank you. Thank you for watching.